The world of linear equations makes math so much more fun to do. Today, we're going to dig a little bit deeper. We're going to start to talk about the slope of the line. Now, you know linear equations simply are equations that form lines on the coordinate plane. And we've already talked before that those lines can either be a positive slope, a negative slope, a zero slope, or something called undefined. Now, what exactly does it mean by slope? Well, it just means it's the steepness of the line. And we know that as the line gets more and more vertical, it becomes steeper. So when we read slope, we always are reading the coordinate plane from left to right. So if it goes up from left to right, that has to be a positive slope. If it goes down, it has to be the negative. If it's horizontal, that's zero slope. We're just on a flat surface. Or undefined means we're dropping off the cliff. Now, when we talked about the linear equation, we said that the proper function form for linear equations was y equals mx plus b. And we've talked about the x and we've talked about the y, but we have not talked about this m or this b. And today, it's when we get to start to talk about the m. That m in that formula simply is talking about the slope or the steepness of the line. And so when we take a look at that m, it's actually a ratio. And that ratio is what we call rise over run. Now, what does that mean? Well, rise means the movement on the y-axis. It's that up and down movement. Run is the movement on the x-axis. It's that left to right movement. Now that movement can be a positive movement, so I could have a positive ratio of 1 to 2. That means my line is going up from left to right. That slope or that ratio could be a negative ratio. So that'd be like negative 1/2. That means it's going down from left to right. The slope, if it were a zero slope, would have 0 on top, but a number on the bottom, because it is a ratio, and it's that movement, remember, on the bottom is that left to right movement. And if I have an undefined slope, it means that I'm going to have movement on the up or down or the y, but I don't have any movement on the x, so that 0's on the bottom. So when we take a look at the ratios, it's really talking about the movement up and the movement side to side. So that's all that we're talking about when we're talking about slope. Well, how then do we find slope? Well, there's two methods, and it depends on the information that's given. So one way you might be asked to find slope is if you're just looking at a line on a coordinate plane, such as this. Well, that's the easiest way to find it, because all we need to do is we need to figure out how far up or down it moves on the y-axis and how far left or right it moves. And what we're talking about is from point to point. So say I have these points here. I have a -2, 1, a 0, 2, and a 2, 3. And I've already graphed those points. They're already there. Well, if I'm going to calculate the slope, first I have to do my rise or my movement on the y-axis. So what I'm doing is I'm calculating how far does it take me to go up to where that next point's going to be. Well, I'm starting at 1 and the next point is at 2. That means I moved just 1. So now I'm going to check it here. I started at 2 and I went up to 3 and I just moved 1. So that rise has to be a 1. I'm always moving up 1 space. Now I'm not done because I have to take a look at that x-axis too, the movement. So when I went up 1, how far did it take for me to get over to where that point is? Well, it took me 1, 2 spaces. So I think it's 1 to 2. But now I'm going to check again. I go up 1, over 2 spaces before I hit the next point. So always, if you're going up and over and you're looking at a line and you're calculating from one point to the next, that is one way to find slope. Now remember, the slope is a single slope per equation. So this line matches an equation. There can't be a different slope between one point and the next. Slope is consistent. That's what's giving us that consistent line. It's just talking about the steepness of that line. Well, sometimes they don't give us a graph, so we can't just count it out. A lot of times what they're going to do is they're just going to give you an ordered pair. And if that's the case, then we use a formula for slope. Now, rise simply means the difference in movement on the y-axis. And to find the difference, it's always subtraction. And so what we're going to do is we're going to take our y values of 2 points, and you have to have 2 points in order to do this. If they gave you just 1 point, you don't have enough information. So if I have 2 ordered pairs, that means I have 2 y's, and I'm going to call each of those y's a different thing. I'm going to say this is y1 and that is y2. And in order to find that rise, I take the difference. Now the standard formula is y2 minus y1. And then on the bottom, it's the change of the x-axis, and we do x2 minus x1. That's the formula you're going to see in most math books. However, I do want to tell you, it doesn't really matter the order that you subtract as long as you're consistent. So if you start with 2 here on your y, you have to do 2 here on your x. And if you end with y1 here, then you have to end with x1 there. So what I did is I took this ordered pair and I'm solving it first doing y2 minus y1 over x2 minus x1. Then I reversed it and I did y1 minus y2 over x1 minus x2. And my point here is for you to see it doesn't matter the order, whether you use the first or the second. All you have to do is be consistent. So when we go to do that, I literally take that ordered pair. So I'm going to go to y2 and I see that's a 2. And I'm going to subtract, because you always subtract. It's the difference between them. And I go to y1 and that's negative 1. Now don't forget to put the negative there. That's the subtraction sign. That's the integer sign. Well, we know that 2 minus negative 1 is really like 2 plus 1, so we know that's 3. So that means that movement on that y-axis from one point to the other is you're going to go up 3, up 3. Now, I still don't know my left to right movement, so then I have to do my x's. So my x's, since I did y2 first, I got to do x2 first. So I'm going to do 4 minus 1, which is 3. I get the ratio 3 over 3, and we then take that to its lowest terms or simplest form. We'd say that slope is 1. Now, many of you are going to say, but I think it has to be a ratio. If you want to show it as 1 over 1, you could always do that as well. But it's okay. We can have a whole number as a slope here. And we'll talk about that a little bit later. But let's reverse it. Let's say that I wanted to do y1 minus y2 over x1 minus x2. So I'm just reversing the problems. Well, again, when I fill it in, all that happens is I get a negative 3 over negative 3. Notice my answer's the same. So it doesn't matter the order that you do this. You don't have to follow y2 minus y1. If you'd like to, it'll work, but it'll work either way as long as you're consistent. So today, your biggest job is to be able to find slope. And you're either going to do that by reading the graph or by being given an ordered set of ordered pairs. So it's up to you. I know you're going to be able to do well with this. Good luck.